everyone, I am Janapati Srinu. Who are watching first time my video, subscribe my channel and share to your friends. We already discussed about solid state unit for the examination of TSCPGET and APPGCET entrance examinations. So I am continuing the video for those part 1. So that is laws of crystallography. Laws of crystallography. So some laws are there, that is not required, but the thing is you should remember some terminology here, that is Miller indices. Miller indices HKL values, right? Miller indices HKL values. So first I am going to discuss the question. If you know the question, then you can solve the how to solve the Miller indices planes. A crystal plane having intercepts of A, 2B and 3C along the axis, crystallographic axis. So then what are the Miller indices? We have to find. That is a question I am writing. A crystal plane intercepts at A, 2B and 3C along crystallographic axis, crystallography axis. Then what are the Miller indices? This is a question. Very simple concept. If you follow the concept thoroughly, you can get the marks easily. So this is small concept for you. A crystal plane intercepts at A, 2B and 3C along crystallography axis. Then what are the Miller indices? You should remember A, 2B and 3C. I am going to write here A, 2B and 3C. Right. A, 2B, 3C. First you should write the V's indices. The term you should remember, V's indices. V's indices means coefficients for this. A coefficient is 1, you should write 1 comma. B coefficient is 2, then C coefficient is 3. This is called V's indices. Write the reciprocal. Reciprocal means just reverse. So 1 by 1. You should write 1 by 1. And 1 by 2. Reverse for this 1 by 2. Nothing is there means 1 by 1. Here by 1 by 1. 1 by 2 and 1 by 3. Now take the LCM or simple multiplication number. 1, 2, 3 or 2, 3 LCM is 6. So now multiply those number with 6. Then you will get 1 by 1 into 6, 1 by 2 into 6 and 1 by 3 into 6. 2 1s are 2 3s are 3 1s are 3 2s are. So 6 3 2. 6 3 2 is called Miller indices. So those called HKL values. Those are called HKL values. Very simple concept. Write the coefficient, that is V's indices. Then reciprocal of this V's indices you should write. Then multiply with the simplest number, that is LCM of the denominators. You will get the 6. So you will get 1 by 1 into 6, 1 by 2 into 6. If you will cut this 6 3 2, that is HKL, that is called Miller indices for A, 2B and 3C. So we will solve some 2 to 3 problems, then we will get clear idea for this. So next example I am giving. Same question, but the intercepts, or you can say crystal plane intercepts at you can write 2A, B, 3C. Now pause and solve the question. Next question, same A, B by 2, then 3C by 2. This is the one more question, right? What I told you, first you should write the V's indices, right? V's indices. What are that V's indices? Here 2. Coefficient, A coefficient is what? 2. And B coefficient is what? 1. And C coefficient is what? 3. So then V's indices we wrote. Reciprocal you should write. Reciprocal value. What are the reciprocal? 1 by 2, then 1 by 1, then 1 by 3. Now take the same simplest multiplication number. If you multiply, what happens? 1 by 2 into 6, again same. 2, 3 LCM is 6. 1 by, this is 1 by 1 into 6, then 1 by 3 into 6. Here you will get 2 1s are 2 3s are 3 comma 6 comma 3 1s are 3 2s are 362 is called HKL. That is nothing but Miller indices. Miller indices. This is the one example for this plane. In examination they will give the 2A, B, 3C. For this you should write the HKL values. The answer is 362. Like this you have to solve. First we will write the V's indices. For this is the second question. This is example 1, example 2. V's indices. What are the V's indices? Here 1 coefficient is 1 is there. Here 1 by 2 is there. Here 3 by 2 is there. Next, write the reciprocal. What is the reciprocal value? Reverse, just reverse. 1 by 1. 2 by 1 is nothing but 2 by 1 you should write. Then here 2 by 3. What is the 113? LCM of 113 is nothing but 3 only you will get. So next multiply with 3. Multiply with 3 means you will get 1 by 1 into 3, 2 by 1 into 3, then 2 by 3 into 3. Multiply with all. So then you will get 3, 3 2s are 6, then 3 cancel, you will get 362. This is HKL. This is called Miller indices. For this question, Miller indices is we got the 362. For this question, Miller indices 362. Now we can going to give some conclusion that if the planes having the same Miller indices, those planes are called the parallel planes. Now you can say 2A, B, 3C, A, B by 2, 3C by 2. Those two are called parallel planes because those having the same Miller indices value. This is the conclusion. I am going to give the conclusion further. Next, the distance between any two successive planes. The next statement is the distance between any two successive planes is called the interplanar distance, DHKL. The distance between the any two successive planes is called the interplanar distance, or you can say DHKL. So for this, any system, the value is DHKL whole square is equal to h square by a square plus k square by b square plus l square by c square. This is the formula for interplanar distances applicable for all crystal systems. Applicable for all crystal systems. So generally, many of the people they are thinking that the general DHKL formula is a by under root h square plus k square plus l square. This is a general formula they will think, but this is the general formula. This is applicable for all crystal systems. We have the 7 crystal systems. Already I discussed earlier video. You can see the solid state video. 7 crystal systems are there: cubic, tetragonal, orthogonal, hexagonal, monoclinic, next to trigonal or rhombohedral. So you can say monoclinic, triclinic. Those are there. Lot of the 7 crystals are there. So this is the general formula. This is for cubic system. I will explain how we will get this formula. Right, for cubic, right? What is a cube? Cube is like this, right? For cubic, this is, if I say x-axis, y-axis and z-axis, A, B, C. All lengths are same. You can say simply A. All lengths are same means A value is same, B value is same and C value is same. So for this I am going to take single. All are at same means 1 by d square HKL is equal to h square by a square. All are same means I am taking only a. K square by a square plus l square by a square. Now next step, 1 by DHKL whole square is equal to, so now the LCM is a square only, so you will get h square plus k square plus l square. Right. Next, if I write reverse, you will get reverse means just reciprocal. D square HKL is equal to what you will get? A square by h square plus k square plus L square. This is the value you will get. If I want to remove this, you will get the square root. Square root here, square root here. Square root cancelled. So you will left with only a. So the DHKL value for this is simple cube. That is what? A by under root h square plus k square plus L square. But for all crystal system, 1 by d square HKL. That value is h square by a square plus k square by L square plus b. So that is L square by k square by b square plus L square by c square. This is about all crystal systems interplanar distances. I am giving some conclusions for this. If h is equal to 0, if I say h is equal to 0, that means that is parallel to x axis. HKL value, I am talking especially. K is equal to 0, that is parallel to y axis. L is equal to 0, parallel to z axis. If h comma k value is equal to 0, that is parallel to xy plane. This is axis. Mind, keep it in the mind. This is axis, and here it is the plane. If KL is equal to 0, that is parallel to YZ plane. If h, that what is the remaining? H and L value is equal to 0 means that is parallel to XZ plane. This is the conclusions you should remember. H is equal to 0, K is equal to 0, L is equal to 0. HK is equal to 0 means XY plane, KL is equal to 0 means YZ plane, and HL is equal to 0 means XZ plane. Very important concept. Next I am going to discuss about what is the values for simple cube, what is the planes, right? What is the planes for the simple cube, BCC and FCC. So for example, simple cube, BCC, FCC I will take, right? For simple cube, HKL value, any, you can take any possible HKL value. So for simple cube, any HKL value you can take. Any HKL value. That means even numbers or odd numbers, both even odd combinations are possible. For BCC case, the H plus K plus L value must be even number. If you take some plane, for example 1, 1, 0, right? So the sum should be even number. 1 plus 1 is 2, 2 plus 0 is 2. So you will get even number. So some like, so H plus K plus L must be even number. You can say simply H plus K plus L must be even number. For FCC, HKL value either may be even or odd. Either even or either odd. But even odd combinations are not possible. Either may be even or either may be odd. So the even odd combinations are not possible for HKL value. So I will explain how the values are like that. If I will take any combinations like 1, 0, 0, this is the plane, 110, this is the plane I am going to take 111, any value. So this is belongs to simple cube only, 100, 110, 111. So for BCC I am writing the value should be, sum should be even, 200, 110, you can take any value, 222. This is a 2 plus 2 plus 2 is 6, 6 is even number. So this is simple cube, this is a BCC, and FCC I am going to discuss. So you can say only either even or odd. Here I am taking 200. If I will take 220, it is also even, it is odd. But even odd combinations are not possible because this is even number, odd number. So that means either should be even number or should be odd number. This is about the very important concept. You can expect question from this. They will give, for example, 110 belongs to either BCC or FCC. What is that? The value should be even. So you can say like this: simple cube, BCC and FCC. Next, representation of planes. A representation of planes. A representation of planes. So I will tell you trick to how to remember the planes number. For example, if someone gave one plane to you, this is x-axis, this is y-axis, this is z-axis I am going to take, right? One more structure I am writing here. X-axis, y-axis, z-axis. So here x-axis, y-axis, z-axis, right? This value is 0, r is in 0, this is a 0, right? So first I will explain the plane I am writing. This is the back side plane, right? So back side plane. So if I will write the same plane front side, you will get like this. This is the back side. Plane means just if I am taking the cube, just you should observe that this is the back side. So if the same cube, front side, both are same, right? For this, how to write the HKL value? So this I am writing the HKL value is 100 HKL. Here also same 100. Here HKL. So what I wanted to say that, so this touches y-axis and z-axis, right? This touches y-axis, z-axis. Same plane, this touches what? X-axis only. This touches x-axis only. So the length you should take 1. Just remember like this 1. So 1 by 1 is nothing but 1. The remaining is 0. 100. So you should write HKL. So like this, whenever some plane is like this, just you observe front side, you will get the line touches here YZ. YZ is equal to 0 means, that means parallel to XY plane. The YZ means what? This is K comma L value is 0 means parallel to YZ. So same you should write. So that you should write here front side. So you will get like this. This is touches x-axis. You should write 1. Whenever touches x-axis, you should write 100 HKL value. HKL value. Right. Okay. Same similarly, if I write you, so this is the value. If I am writing, so next I will write. I will explain. HKL value 100. If I will take some other plane, right? Some other plane is like this. This is x-axis, this is y-axis, this is z-axis, right? So now I am going to take plane, right? What is a plane? Plane from this. This plane is what? This is touching XZ plane. This is called XZ plane. Or same plane if you will take from here to here, both are same, right? This plane touches y-axis, right? Hence I told you whenever single axis it is touching, you should write 0, whenever y-axis touching 0, 1, 0. This is HKL. Right. Next, one more example. For YZ plane we will discuss. This is what XZ plane. If I will write YZ plane, how is this? This is y-axis, x-axis and z-axis. YZ, right? Where is YZ? This is YZ. You should write. Sorry, this is XY plane. YZ already we discussed starting only. This is what? XY plane, because you can say here it is XY plane. X and Y is there. This plane and this plane both are same, but this touches with z-axis. So I told you now, this is x and this is y. XY plane. So it is touches with z-axis. You should write 0, 0, 1. Both are same. If you will, if they will give this only, or if either they will give, like if someone will give this, what is the answer? 0, 0, 1. If someone will give, what is the answer? 0, 0, 1. Because that is touching the z-axis. If same plane, but the same plane same, if you will write like this, this is what? Parallel to XZ plane, means it is in between. In between means generally it is 1 by 2. From here to here 1 by 2. 1 by 2 means just reverse, you will get 2. This is 0 to 0 plane. That time you should write half means reverse, you should write 2, 0 to 0. Same plane like this, if you will write in between, middle, you will get what? 0, 0, same 1 by 2, 0, 0, 2. Previous also same. You will get 2, 0, 2, 0, 0 plane. 2, 0, 0 plane, right. Next, some more examples are there, simple. This is x-axis, this is y-axis, and this is the z-axis if I will take. So now I am writing. This is a rectangular plane of symmetry, already we discussed. Where it is touching? Where it is touching? Rectangular, x and y. The values are 1, 1, 0 because h, k, l value is 1, 1, 0. If I will take other plane, other rectangle like this, other rectangle if I will take like this, here touching here and here, this is x-axis, this is z-axis, this is y-axis. Hence x and z values are 1. So you should write 1, 0, 1 plane. Here 1, 1, 0 plane. Some other plane is also there, that already you should write like this. Simple. It is touching this and this. So hence it is y, z. So yz value is 1, 1, 0, 1, 0, 1, 1, 0, 1, 0, 1, 0, 1, 0. This is about some other planes. If I will take last examples for this plane. If I am taking the cube like this, I will write to take all the planes. R value is 1 only, right? X, Y, Z. So 1, 1, 1 plane. Same concept, if I will take half of the value of that, what you will get? Half of the value means this is 0, this is 0. Half means right like this. The shading area is like this is half means 1 by 2, right? 2 to 2 plane, because this is x axis, y axis, z axis. So this is all about a representation of planes. Next, Bragg equation. In this video, this is the last concept, Bragg equation. I am going to give only final formula for this Bragg equation. Generally, Bragg equation is what? N lambda. You should read by heart this. N lambda is equal to 2d sin theta. In examination point of view, they will give the n value and lambda value and d value. They will ask to find out the theta value. They will ask to find out the sin theta value. So here n means what? Order of reflection. Order of reflection means whether it is n is equal to 1, 2, 3. Order of reflection. Lambda means what? Wavelength. Lambda means wavelength. And d means interplanar distance. Interplanar distance. Interplanar distance. And theta means angle. Reflection angle. Reflection angle. Reflection of angle. And d means interplanar distance. This is the Bragg equation formula. They will give any one of the value. They will ask to find the theta or d value, anything. So just if for competitive, for higher examinations, so write the square on both sides. N square, lambda square is equal to 2 square is 4, d means d square, then sin means sin square theta. If I want to write sin square theta, the remaining terms comes here. Sin square theta is equal to n square lambda square by 4 dr square. 4 dr square. So you can know also d square, right? D means what? A by under root. So d square means what? D square is a square by under root h square plus k square plus l square. This is a d square. If you wanted to write d square value, you should write a square divided into under root h square plus k square plus l square. If you want sin theta only, you will get square means n root. Square root means you will get n lambda by, here you will get 2, square root cancel a, you will get h square plus k square plus l square. This is the important formula they will ask for the competitive examinations. And final formula, if they will ask, find out the angle between the planes of 100, otherwise 110 and 111. If they will ask question like this, find out the angle, you should write the formula cos theta is equal to h1 h2 plus k1 k2 plus l1 l2 divided by under root h1 square plus k1 square plus l1 square, here under root h2 square plus k2 square plus l2 square. They want to ask something value. This is what? h1 k1 l1 h2 k2 l2. Just substitute h1 into h2, 1 into 1 1 plus k1 into k2, 1 into 1 plus 1, 0 into 1 0, you will get under root h square plus k square plus l square. 1 square plus 1 square is 1 only 1, 1 plus 1 is 2, so you will get root 2. Here h2 square plus k2 square plus l2 square is 1 square plus 1 square plus 1 square is 3, so you will get root 3. So here what? 2 by root 2 into root 3. So 2 you can write root 2 into root 2. So 1 root 2 cancel, you will get under root 2 by 3. So cos theta is equal to 2 by 3 and theta is equal to cos inverse root 2 by 3. This is the formula for theta. This is the questions they will ask in the examinations. If you like my video, subscribe and share to your friends. Thank you so much.